I am Jos Schellevis from Deciso, and today I want to talk about open source and specifically securing your network with open source software. And together with Randy Caldejon from CounterFlow AI. Questions, if you have any question, please leave it for the end, because we have so much to tell you. If we run out of time, find us at the booth and we'll gladly answer all the questions you have. Well, we have very much exciting stuff to tell you today. So I want to talk a little bit about Deciso, who we are, and give Randy some time to explain CounterFlow. Then I'll introduce OPNsense. And Randy will talk about OPNids or OPNids, as we call it too. So Deciso is a globally operating manufacturer of network equipment. So we make software and hardware equipment. And we design and produce complete products for OEM, resellers, and integrators. And we believe in the power of open source. Open source is very important for our business. We believe in sharing, we believe that it makes better products, and we actively contribute to open source community with our project OPNsense and with OPNids. And we were founded in 2000 and are located in Middelharnis, the Netherlands. And if you ever are around there, please come and visit and grab a cup of coffee with us. And not all at the same time, if that's possible.
So I realize this is a vendor-neutral area, so make it quick. We're not going to talk about too much about our marketing, but just our capability. So we're a fairly new company, 15 months old. There are 12 of us, and we're focused on three things: packet capture, streaming analytics, and data visualization. And we're based out of Charlottesville, Virginia, which is about 2 hours south of Washington, D.C.
So OPNsense. OPNsense is an open source, easy to use, easy to build security platform with a strong focus on security and code quality. And that means we really find it important to have an open source project that's, well, it's run correctly and it's professional. So we have code standards, we have get a pull request, and we ask people not to make them too big. So we are forked from PFSense and Monowall in 2014. And have departed since very quickly, and only 10% of the code looks similar. And our first official release was in January 2015. And our mission statement is to make it just the mostly widely used open source security platform. And it's important for us to give everybody easy access, to give users, developers, and businesses a friendly and stable and transparent environment. So if you want to contribute, if you want to do anything within our project, that should be fairly easy. And we love you to join. And the project's name is derived from OPNsense and stands for Open Source Makes Sense. And that's, well, how we feel about open source. I think open source is very important for today's business. And if you look at what IBM did last buying Red Hat, I think that's a very big dot on this, and it's an exclamation mark for how important open source is these days. And OPNsense is, well, if it's a security platform, it ranges from everything. We do simple firewalling, captive portal, load balancing, high availability, you name it. It is feature complete. And if you see the picture, you'll see a Swiss Army knife, and that's how we feel the basis of the product. In the heart of the product, we have Suricata, and it has been a very important part of the product. We have integrated it in such a way that it's easy to use for everybody, like small and medium businesses. So that's also our market. We try to make it easy by a user interface that everything can be done and administered through that interface. And it's for small and medium businesses. That's our core business, to say so. And then on top of that, we have data centers and enterprises, and we try to get into that market. And together with Accolade, we are able to do 10 gigabit inline IPS on commodity hardware. We have school networks for education purposes, but also just for having a good firewall. They use OPNsense. And for developers, we provide a secure and a manageable platform. So you can build anything on top of that. We have a framework, an MVC framework, And you can use that for anything you like. You can build your own applications with it. You can use parts of our system to make your own application. And two examples, OPNids, that we will talk about later, and Sensei is a tool for next generation firewalling purposes on top of OPNsense. It's a plugin made by Sunny Valley Networks. Google it and you'll find out more about that. If you look at what I mean with easy to administer, then you have two pictures here. On the right side, you see a picture for the intrusion detection system, meaning Suricata. And you see it has categories. I don't know if everybody can see that picture, not that big, but on the right side you see a bunch of categories from abuse, from ET open, and you can select different rules sets, apply them, and if you want, you can change the behavior from alert to drop, and it suddenly becomes an inline system. And you can apply the rule sets by just one click. So a simple administrator, a simple IT guy somewhere in a small company can do this without any knowledge of Suricata or rules. On the left side, you see another example of the firewall. We have firewall logging, live log view, and you can see alerts or events as they happen. So you can see pass, you can see block, and you can use regular expression to filter that traffic. And that's also, well, it's a very simple way of doing things, we believe. So the project has grown very, very fast. We have 134 releases in the last almost 4 years. A lot of them are minor releases, introducing new security updates, and also some minor feature updates. We have 8 major releases since our conception, and that's 2 a year. 1 in January and 1 in July. We have a fixed roadmap. We have 30 active contributors and more than 100 authors in total. And that's only for a project that's around 4 years. We have an average of 100 commits per author, and we have an install base of more than 28,000 active installations as of today. So we are also introducing something very, very, very nice today. As a founder of OPNsense, we believe that sharing knowledge creates better products, and that's the core tenet of open source. And it's the primary driver for our business for the past 18 years. And sharing is the foundation of open source, sharing sources, sharing knowledge. And today we'll add sharing telemetry to OPNsense in collaboration with Proofpoint to enable any user to effectively protect their network by combining the power of Suricata and the ET Pro rule set. And I'd like to invite Brad to explain that to you.
I'm Brad Woodberg. I'm the product manager for ET Pro. What if I could tell you that there's a way that you could leverage the acclaimed ET Pro rule set in a turnkey solution which has all the great networking features and functionality that you want, while not only helping to protect your organization, but helping the community, at large, because you can effectively help our signature development in a way that really requires no additional effort on your side, and all of this is at no additional cost, for free. And with that, I want to introduce a partnership between the OPNsense team and Proofpoint for ET Pro. So let's talk about what this is. So by default today, OPNsense includes ET Open in addition to Suricata, totally free. You're welcome, to use that, and that's great. Basically, anything that's contributed to us from the community goes through a full QA check, or if we write any rules based on community research, all those go into ET Open as well, even if Proofpoint wrote them, Proofpoint Emerging Threats. But for all the other rules that are generated by our own intellectual property, which is typically on a factor of 5 to 10x per day per release, we're releasing ET Pro to ET Open. With this new integration between Proofpoint and OPNsense, basically you're getting what we're calling ET Pro Telemetry Edition at no additional cost. And what that does effectively effectively is there's a anonymized component inside of OPNsense that'll just give us anonymized telemetry logs back so that we can effectively research and understand how our rules are being used in the wild, and whether they're for ET Open or ET Pro. Help us to detect new threats in the wild and to make sure that our rule sets are of the highest quality. We should have a beta, I'm hoping, in this quarter, basically between now and the end of the year. And then, as Yas mentioned, in the 19.1 rule set, we would be making this fully GA to everyone. So just a few points that I wanted to make just on some questions that folks have asked me about this integration. And I should also mention I'm going to be doing a lightning round as part of just ET in general roadmap, so we'll be able to talk a little bit more about some of the great things that are coming to ET in there. But first off, is there any kind of limit to how many sensors I can participate in this? And the answer is really no. At this time, you can involve as many as you want. What's the difference between full ET Pro and the telemetry edition? The main difference is that there's basically we're not including some rules that aren't high fidelity indicators for malicious activity. So for the most part, our rules are, it's going to contain all the best rules, all the things that you guys really care about. There's some rules that are, of less useful value, and that we're not going to include it as part of that. But even many of those are actually in the open rule set, and so you can incorporate those just the same. But it's going to have all the greatest stuff that we're known for, all the command and control, exploit kit, credential phishing, all that stuff that you care most about will be there. What information would be sent back if we participate in this? So basically, we're going to be including just a kind of a stripped down fast log. We won't actually know who the end user is. It's just going to be a UUID so that we can understand that, hey, these logs are coming from the same place. But there won't be any IPs from your organization or anything like that. It's really just going to have the the bare essential attacker information in the signature that fired, and we will include the full sample of the rules, the telemetry, so you can see exactly what you'd be getting. This is opt-in, as I mentioned, so by default, this wouldn't be sending back. And it is ET Pro. You are getting the rules updated every single day, so we have lots of great stuff that's coming out. Like I said, it's an automatic thing once you opt in, so there's nothing that you need to kind of care and feed, and you're getting all this in a really great platform, which is OPNsense. So for beta access, you feel free to reach out to me, Brad Woodberg, which is bwoodberg@proofpoint.com, and we can get you set up, and we'd love to hear from you. Thanks so much, and thanks especially to the OPNsense team for being great partners.
Great. So I'm Randy Caldejon, and so OpenIDS is really born out of OPNsense. And in the spirit of community, Suricata, we had a conversation with Josh, I don't know, about a year ago, and then we met in Prague, last SuriCon, and then our team visited them in the Netherlands this April, and we started brainstorming about integrating the machine learning engine, which is a topic I introduced at SuriCon in Prague in 2017. So we asked the what if question. What if we integrate this machine learning engine on the tail end of Suricata with a distro that was just a full distro with an image where somebody could literally be up and running in 5 or 10 minutes. So OpenIDS really is the manifestation of that conversation. And so this is what the stack looks like. We've inherited everything from OPNsense in terms of the operating system, the UI. Then we have Suricata, obviously, we're running there. It's a tailored version of Suricata that works with our streaming machine learning engine. And so we call this OpenIDS. And that's the reason there's yet another distribution, right? As I can remember, there are 2 good distributions out there. There may be more, but there's the Security Onion. Many of you are familiar with that, where you can install and run Suricata. And there's also Celts from Stamus Networks, and they've done a great job of building an image, so you could literally install it and be operating in minutes as well. With the OpenIDS, we decided to take a different route for the sake of diversity, and so we're actually running on FreeBSD. If you're not aware of this, but PFSense and OPNsense, so OPNsense inherited from PFSense, and we inherited from OPNsense, but it's all FreeBSD. So what are we trying to do with machine learning specifically? Here's the challenge in the industry, and I'm basically preaching to the choir. You're very familiar with this, but we know that the networks, the velocity is increasing, the volume of data is increasing, and the threat actors are becoming more and more sophisticated as well. The real issue is that there's a shortage of security analysts out there. And many of you here can nod your heads because you're the analysts. You're the ones dealing with this day to day, and you're practically overwhelmed. We think that machine learning is a perfect fit. We don't think that machine learning is the answer to everything, as some would claim, but there is some merit in machine learning. For example, when you train models, they basically learn from data. So as we're capturing more data and the volume is going up, we actually can benefit from this. More data means a better model. The model's actually generalized, so it's a little different than actually writing specific rule sets. And so we can benefit from the generalization to be able to detect the sophisticated attacks, or what some would call zero-day attacks, i.e. attacks that have no known definition at that moment. And it's conducive to automating repetitive tasks. So the pattern matching, the machine learning is quite efficient and quite capable of detecting things that either one, we can't define, or two, we can't identify with the human eye. So what we're doing in OpenIDS is focusing on one particular use case, and we call this alert triage. It's a French word, and Eric, correct me if I'm wrong. It originates from the word triar, or triage, which really means sorting. And the history of this is the Surgeon General, the chief surgeon for Napoleon, basically was tasked to deal with this, with casualties, and they were having issues attending and being able to take care of all the soldiers that were wounded. And so created a system basically to three categories. One is needs immediate urgent attention. The other one is no urgent attention. So one's immediate, urgent, and not urgent. And so they basically had three categories. And by using these three categories, they were able to justify their time and basically focus on the folks that needed the most attention. So what we want to do is the same thing with our machine learning engine, is do alert triage. So most of you should be familiar that SuriCon actually puts out what I call two types of streams. One of them is alerts that are triggered on rules. And the other one is really a stream of NSM data, EVE, JSON. And you can configure SuriCata to turn on the HTTP or the TLS or DNS, et cetera. So what we've done is we're able to, with the machine learning engine, to take that data, apply some data science, and keep those features in memory, and then use the machine learning engine to do some alert triage, to either classify or score these alerts in three categories. Obviously benign, so don't waste your time, or questionable, maybe needs a little bit more research, or malicious, let's go ahead and move that up to incident response or escalate it. So I'm going to take the next few minutes to talk about Dragonfly. The motivation behind it is we call the Dragonfly because the Dragonfly actually has a compound eye with many facets. And so the Dragonfly engine is able to run many analyzers concurrently, not just one. So you can run n number of analyzers, one looking at DNS, one looking at TLS, or whatever you want to analyze in a concurrent fashion. The other thing we want to do is we just want to advance the state of machine learning and cybersecurity. And we believe that the best way to do it is through open source. No closed black box. An analyst or a data science can look at the code, look at the analyzers. It can be peer reviewed. We can all benefit from that. Andy and I were at a conference earlier this year, FlowCon, which is another conference we like to go. And this year was the first time they introduced, or they opened the theme of the papers, the presentation around data science, which is very good. But we found it interesting because it was a crowd that was typically attended by security analysts, and this year over half of the attendees were data scientists. So when the data scientists would get up and talk about their models and their research, you would see the eyes of the security analysts just glaze over. Had no idea what's going on. When the security analysts went up, you would see the reverse. The data scientists just had no idea what was going on. So from that, Andy and I thought, well, why don't we create a machine learning engine as a gentle approach, a way to introduce machine learning to cybersecurity. So a security analyst who wants to know a little bit more about data science could actually run this on their laptop because it's lightweight. Or a data scientist that really wants to know more about the cybersecurity domain could actually run this on their laptop. It would not require petabytes of storage and 100 compute nodes, et cetera, which data scientists usually have the luxury of using. So in terms of design goal, obviously it's going to be lightweight. So it runs on a laptop. In fact, that's how we do a lot of the testing. That's how Andy writes his analyzer. He actually runs it in a Docker container. It's got to be performant, meaning we want to be able to process over 1 million events per second. And right now, that's constrained really by Redis. We're using Redis as a back-end database. But we have some analyzers can run over 1 million per second. It has to be open so that you explain why a particular analyzer scores or does what it does. It just can't be a black box. And the most important thing for us, it has to be streaming. No backhauling of the data to a data center and doing batch processing. So there's a saying in the open source community, you guys have heard it, right? When we say that the code is free, free as in beer, that resonates with you. So I'd like to introduce another thought is streaming as in beer. And I like it because it's a great picture. You know, you're dealing with windows at a time, a cup at a time. You're savoring the flavor, the bitterness, the maltiness. Unlike this is not streaming where you actually send all the data to the data center and maybe you process it weeks at a time or a month at a time. Nobody likes skunky beer. So the whole idea for the machine learning engine is to work in a streaming fashion. So in terms of the technology stack, it's written in C. And then the analyzers are Lua scripts. And what we do is we spawn 1 thread per VM. So if you have 10 analyzers, each analyzer is running within its own Lua container or Lua VM. We're using Redis as a backend. Most of you are familiar with Redis. Redis is a fantastic, I call it a data structure server. There's so much you can do with it. You can store data. There's linked lists. There's all kinds of things you do. So it's perfect for a data scientist. If you can come up with different approaches or scenarios for analyzing, and you can leverage Redis. You can use it as a message broker as well. And one of the most important things, one of the reasons we like it is that actually Redis has a plugin architecture. And so they've actually released a plugin, a Redis ML plugin. And we're currently using that as part of the Dragonfly machine learning engine. But in the future, we'll probably swap that out and run a different version that's more conducive for cybersecurity. But we'll continue to use Redis and the whole API so that if you're working with the Dragonfly machine learning engine and you want to use something else, you can swap out the back end because it's got a pluggable architecture. So this is what a typical pipeline would work. Suricata is a source of the data. It would spit out Eve JSON, and then Dragonfly actually you can use a file input processor. Works much like Tail. So you point it to a file and it reads one record at a time as Suricata writes it to the eve.json file. Or another way to do it is we can use Unix domain sockets, which is a lot faster. So you configure Suricata to write its output to a socket, and then the Dragonfly machine learning engine will read from that just as fast. And in the analyzer, there are two types of analyzers. There's what we call analyzers that analyze, and there's a script that you can actually define that's called a filter. And what the filter does is it knows the format of the streaming data. So in this case, it's EVE or JSON, and so we have a filter that knows how to read or consume Suricata JSON. But if you were using some other product or some other tool, you could write a filter to do conversion. For example, it's a comma-separated records. You could write a filter for that. So from there it goes to the analyzer, and then you do your analytics. You can store some data in Redis. You can do sliding windows, and eventually you'll want to do some output, and the output could be a file again. You can put it over to a Kafka message bus, and because it has a plugin architecture, you can write your own output module for it as well. This is what I like the best about the way we've designed the machine learning engine. So, the file represents the input from Suricata. We write a DNS analyzer, and then it goes to an output. But there's nothing to constrain it to say it only goes to one output. You could actually send it to two outputs. So you can feed the output of one analyzer as an input to another analyzer. And so it almost reminds me of a neural network. It's not a neural network, but the point is you basically have a network, a graph. And with the configuration file, you can define your own processing pipeline using the Dragonfly machine learning engine. So that means you can do some advanced analytics as well. So it could be simple or it could be complex. So Dragonfly engine is all about the analyzers, and so here are some examples of the type of analysis you could do, which is typically the type of analysis you can't do with rules. Sequence analysis, so the sequence of the length and the interarrival time of packets. Time series analysis, for example, is this type of connection to this machine typical at 1 o'clock in the morning? So you can ask that type of question. Statistical analysis, the byte distribution, packet distribution, graph analysis in terms of relationships. And then you can do a simple lookup. So if you wanted to download a threat list, a reputation list, and I am aware that Suricata has this. One of the nice features is this, that you can change it, it's dynamic. So you can actually load a new rule set and instantaneously switch it out. Or you can update it on the fly. Because it's using a Redis backend, you can add bad IPs dynamically as well. So that's a simple case of an analyzer. What does an analyzer look like? Well, if you're familiar with Arduino programming, we try to make it as easy as possible. There are really two entry points, two functions. One is setup, and that's called at boot time or whenever the process runs. And this is where you do all the housekeeping. In this example, we make a connection to Redis. We do a ping to Redis to make sure the communication is working. And then we load up all the parameters of the model here. This is one that Andy wrote. It's on logistic regression. So in this case, we're actually hard coding those parameters, but you can actually write those parameters to a file and then have the analyzer read the parameters from a file. So they're set up just like the Arduino code, and then there's loop, right? And loop is really a callback for every time there's an event. So this is where all the hard work is done. This is where the analyzer does its work. And that's it, and it's written in Lua. And so if you're not familiar with Lua, I guarantee you if you had any experience to programming, you could learn it in a couple hours. It's not that complicated. By the same token, there's a lot you can do with Lua. So if you want to do some advanced stuff, you could do it. And we're actually using the just-in-time compiler, so we're seeing, at least in terms of processing events per second, we're seeing performance that's approaching writing the analyzers in C, so they're fairly fast. In terms of the roadmap, we were hoping to release 1.0, but you guys know as maintainers, things happen. So we're pushing it back to December, but we're almost there. There are a couple things we want to clean up and one item that we want to add. The other thing we want to do is add many more analyzers. So we've opened up a GitHub, and so we're hoping to have contributors who come up with some ideas around analyzers. and would like to share it, just like we're sharing it with the community. We're going to add more plugins. One request is for IPFix, to be able to consume IPFix records and then do some analysis on IPFix records. Another neat thing we're doing is Deciso has a new generation of their hardware appliance, 1U. It's out actually in our booth. We've integrated that with an Accolade capture card, acceleration card. So actually, Accolade supports FreeBSD. And so last week we completed the support for the Accolade and Suricata. So that's not rolled into the main Suricata code, but if you Google CounterFlow and Accolade, there's a GitHub repository with the latest code, and I spoke with Victor last night. We're going to do our best to fast track it, and hopefully we'll get it into the mainstream code as soon as possible. But in the meantime, if you want to try it, you can download it from our GitHub account. And, well, just want to thank and recognize the community partners who have helped make this possible. And again, without Deciso's work, there's no way we could have done this in 7 months, actually 6 months. So in 6 months, we were able to do the integration, the branding, the switching out of certain packages, and just build a distribution that really just works out of the box. So even if you're not interested in Dragonfly, want to test or run Suricata on FreeBSD, then you can just disable the Dragonfly machine learning engine and you have a fully capable IDS running on FreeBSD. So I'd like to thank Accolade for the support. I'd like to obviously thank the OISF and Victor for all the work he's done with Suricata. And another company we work with is Graylog, so our OpenIDS. One of the things we did is we tested it with Graylog. We're able to use it, so we actually support file beats. So you can turn that on and you can point it to Graylog. And you can actually see all the events. And so pretty neat visualization for a free piece of software. And I think we're done. Any questions?